Day 50, Honors Physics, Conservation of Momentum, problem number 20. Another classic conservation of momentum, and it's a vector problem with components now because we have one of the objects, or the people, linebacker, traveling at an angle northwest that's 45 degrees. So let's walk you through it. So I have a little diagram here. Here's our running back traveling south at 10 meters per second. So his or her momentum is 1,000 units south. The linebacker traveling northwest, assuming 45 degrees, mass times velocity, 120 times 6 is 720 units of momentum northwest. Now, this is the vector breakdown of components for that linebacker. If they're traveling at the 45-degree angle with the 720 units of momentum, the two components, north and south, basically it's a 45-45 triangle, so you can just divide by square root of 2 to get the components both equal. 510 units of momentum north, 510 units of momentum west. Now we have to figure out the total momentum of the system. Well, the easy part's the west because there's only one object moving west, so the 510 by the linebacker west is a component of the total momentum. But what's the total north-south momentum? Well, we have one person going south with 1,000 units of momentum, and the other one with a 500. So what I'm taking is this 500 right here. Oops, sorry about that. This 500 here, and this 1,000. That's 1,000 south, and 510 north gives you a net of 490 north. 490 south, right there. So those are the components of our total momentum. So then I took that way over here to the right. My two components, my 510 west, my 490 south, being careful to put those arrows in the correct direction. So my resulting momentum is right here of the two objects stuck together. So what you're going to do is Pythagorize that. In other words, r squared for the total momentum of the two guys stuck together equals 510 squared plus 490 squared. That will give you the total momentum of the two people, but then you have to get the velocity of those two people. So what you do then, that will be your final momentum, your P total. I'm calling it R, but that's P total. I'll write it down now, P total. So that value that you calculate will go in here, and the mass total now, they're stuck together, is 220. 220. I'm going to call that now V final, or call it V3. That's the magnitude of their final velocity. You'll take that total momentum, divide by 220, gives you the velocity. You also need to figure out the angle. You can just use this diagram up here and use tangent of theta. Tangent of theta would be 490 over 510. So that angle would be then an angle with reference to the westward direction, south of west. But if you have a diagram like this, perfect. I love to see this diagram. In fact, I need to see this diagram showing me all the directions involved and the angle you're computing relative to one of the two component vectors, in which case it's relative to the westward vector.